All right, welcome back. This is part 2 of our class assignment 4, which is where we're looking at the first of the round-to-round transitions or intersections, and this one has like diameters. So we've been working with 3-inch tube for our header and our branch. So we're just going to pick up where we left off in the last video, which is where I had my orientation lines drawn on the branch where they meet the header, and all I've done is just I put my numbering system up there. And you don't have to do this. I'm just doing this as a visual reference here, and I'm just going to talk about that real quick. That's because now I'm ready to take in the right side view. I'm ready to take those lines over to our front view, elevation view here, and this is where you need to know which line represents which line in the view to help me know where to terminate. And we did this kind of work on the first assignment we did, which was just a bevel on a pipe. It's the same situation here. Only I don't even know if I numbered those like this, but so I'm kind of going through this again because we didn't do this much in the offsets, but so if I just look at my initial front view, and I'll click in here and zoom in a little bit. This top of the branch, right, and we've developed that. I've just kind of drawn in these numbers just kind of as if I had this whole circle going around, right? So and that's just kind of why I've put them in this order here. But I just started one here, so I actually came back over to this to my front view and kind of and numbered this the same way we'd kind of done in our dividing the circle exercise, and so as I look at that, this is 1, this is 2 and 12, 11 and 3, 4 and 10, 5 and 9, 6 and 8, and the outside one being 7. So that's all great and dandy. That represents that circle coming across. And so now that I've established like a numbering system with that, if I want to make sure I get the same numbering system in the other view, it just shows that as I look at the right side of that, these outside lines, this becomes 4 and this becomes 10. So it's kind of just looking like, 4 and 10, when I rotate them 90 degrees, they become the outside lines here. So I think what I see a lot of people when they go to draw this is they'll think that that this lines 1 and 7 in this view come all the way down and are the same as this this outside of this branch coming down, and that's not right. So 4 and 10 are the ones that come all the way down to the center line. So that's actually right here. So as I go to project my orientation lines across and make the grid pattern, a lot of times the way I do that first is define the outsides, define kind of the center lines and the outside edges of the pipe. So if that's what I've just done there, lines 4 and line 10 are this center line of pipe, 4 and 10. And lines 1 and 7 right here that actually end at the, in this view, they end where they meet the header, right on the top dead center, like 12 o'clock position of the header. That's what I've got over here. This is line 1 and 7, hits dead center, 12 o'clock on the header, and that right side view kind of proves that. So once I've kind of established those in my mind, then I can worry about the rest, because I just kind of establish one and I just kind of go line to line until I hit those points again. So I just know that as I come across lines 1 and 7, if they are, as they project across, they pick up right here in the view and over here. And then if I was to go to the next set of lines, and the interesting thing about, this being a symmetrical T round around is that 8 and 12 and 6 and 2 in this view are actually, they hit the same place on the header. So the information coming across here, where it picks up like the 6 and the 8 and the 2 and the 12. See, that all makes sense now, see? Even though, like in here, this line is 6 and 2, in this view it's 2 and 12. That just tells you that that grid pattern has the same number. You know, these lines where 6 and 8 share the line here, 8 and 12 share it here. So it just shows that likeness from line to line. And I'm explaining that a little more than maybe I need to, but for some that's obvious, for some that's a little less obvious. So let's just go ahead and project across. And I'll just pick up a line here. So yeah, a lot of times I'll start with a center line on one view or the other. So if I just say 4, 4 and 10, I can just pick them up in this kind of this one point across, but 4 and 10 will pick up and be right there. So I know that's kind of the start of this pattern in this view, and it's kind of up from here. And it's going to look like a V in this view is essentially what I'm going to get. So that one's kind of already been projected across. The next one up, 5 and 3. So this little line comes across and is representing right there, because if I've established this line, it's going to be the next set of lines up, and that one. So I kind of make this grid, and then that tells me that this thing didn't need to go all the way down to center line. This thing needed to end right there, this line that I've just kind of tucked in that view, and same with here. That's actually as far down as it really would have gone. I just didn't have that information until I picked it up from that right side view. So I'm going to repeat my line command on the next set of lines up where they meet the header, bring them across, and really I'm just picking up, if I've started there and hit there, it's these next set of lines out. And they have since I've numbered them, they show that information that they have in common. And because they're symmetrical in that right side view, these two lines they use the same information. So I'm going to tuck these in. Those were just unnecessary extensions there. And then the last one being 0.7 and 1 here are the last two that I really haven't defined, but they really are. They actually terminate right at top dead center of the header. So if I move that branch off center, then that doesn't necessarily isn't the case, but it is here. You know, these do share a center point. Branch and header share a center point here. So really all I need to do is just to complete the drawing is just show that projects across to that 0.7 and 1. So now I've just got these projection lines, and they've made a grid pattern in the front. And now what I like to do is kind of show like a solid line, and I like to kind of show almost like it's a weld joint. So I'll kind of go in red to get some pattern separation here. It's just my own personal choice, and I'll use a polyline for this because this could be. If it's rounded off more, the polyline works great. Sometimes when these are almost truly like a straight line, almost in this view coming down, sometimes this doesn't work. But what I would do is I would grab a polyline, select this point, and I'm going to arc this, A for arc, and S for second point. So this is my second point, and then I select this. And I actually want to show you that. Like, it will not let me drop that. And that's because it really isn't any of an arc. It's actually practically a straight line. So I actually wanted to demonstrate this. That you see me use arc and second point a lot. Here's an application where it just won't drop that second point. So it just won't drop that as a line. I mean, it's basically a line. So if that happens to me, I just kind of realize what's going on, and I just essentially can do lines, line to line, and you get this like, yep, that's what that cut line looks like. Practically a straight line coming off the center line. All right, and that's all I really wanted to detail there, except and I won't do this yet, but now I'm ready to develop there is more information I'll pick up on here, and I'll kind of like do some lines over lines to do that. I'll come back to that when I go to develop the header. let's just finish off and develop the branch, because like I said in the start of the last video, is that sometimes it just takes me to develop a branch to use that. Once I get that, I can use that as my header in the field actually, and lay out the branch, get it all cut out, how it's coped, and then just butt it into the material. And if it needs to have, if you're making like, roll cages, a lot of times you don't have fluid passing through there, so just doing the cope on the branch and butting it into the round header, it doesn't need to be there doesn't need to be a hole in the header. So if you're thinking of like coping tubing for roll cages and frames like that, that's all we need is a branch layout. But if it's actually for a process, for something, a fluid running in the pipe, well, then we've got to open up that inside diameter of the header, which is why I'm going to show you that here, even though you could still use the branch to mark out the header. I'll show you how we can essentially just come up with a header pattern here too. So let's do the branch first. I'm just going to come over here. I'll just stay in red and grab a line. A lot of times you'll see me draw my patterns just kind of how they relate to the drawing that I've drawn. So this is kind of the straight section of my branch. So I'm just going to make sure I'm kind of in line with that. And I'm looking for a circumference line here. So we're working with 3-inch OD tube. So I'm just putting my calculator. 3 times pi, 3.1416. There's my OD stretch out there for paper, right? I really didn't do any subtraction or addition for metal thicknesses here, so that's okay. I'm still working in paper. Haven't thrown out a metal figure out at you yet, but we will. Just stay tuned for that. Okay, so it's 9.4248. 4248. So make this line 9.4248. And go ahead and escape that. So 4248, just not quite 7/16. 4375 would be 7/16. All right. I'm going to go ahead and divide that. So I have my 12 divisions to pull to. Again, I just do a different color just so that I get that kind of separation. You don't have to do that, because when I'm snapping to this, as long as I've got my object snap settings, choosing node, those will come up for me to drop these lines to. So, all right. So there's my branch circumference. I'm ready to copy and paste some lines, and I can really pull all of them from, I get the same information in the front view as I would the right side view. So I can choose. You'll usually see me use maybe the right side view here to pull and drop my lines to. So, but the interesting thing about this is, here's another option where I have the control over where I start and stop my pattern, which could be weld seams on stuff that I'm rolling. I think I'll start my pattern here and then just kind of go in a counterclockwise fashion. And so that's my short seam here. Just kind of what a habit I've been used to, is start my patterns on usually short seams. And then if I need to clock the next piece, I will, however I need to do it. So let's copy these over. So I'm going to start with kind of the 7-1 length of line here. So I'm going to copy them from this base point. It's going to be the start of my pattern. Zoom in just a little bit. I don't know why that didn't drop online. It's okay. Let's see. Okay, and I'm going to drop this one on the other end too here. All right, that looks good. So then I'm just going to work out from there, just kind of keep track of where I'm dropping these lines. So if I kind of look ahead just a little bit, I mean, I know my pattern starts and stops at 7, but if I want to if you can think ahead a little bit, then you could drop that line another time here for point 1, right dead center of the pattern. If we think about coming around this way, and then it's back to that point 1 and back around to 7. But I'll just go there and how I've started and go to counterclockwise. This is point 8. So it actually, would be 0.8 and 12, and that same length of line in this particular drawing it's the same at 6 and 2. So if it helps to like number all these out and then drop those where they go, or you can kind of just work them out this way too. So there's that one, and then if I'm thinking about coming back around, easy for me to think about, that was 8 and 6 is kind of the same, so I'm always usually can go like this with my patterns, like there's that one and that one on the end. I'm going to repeat my copy out to kind of thinking of 0.9 here. So I started 7, 8, 9, and 7, 6, 5. All right, and then I would hit point 10 is my next line, which is kind of like a quadrant or a quarter mark of this branch. So there's point 10, and if I'm thinking about 7, 6, 5, it's also point 4 over here. All right, and then if I kind of started 7. So what you've seen me kind of do is go like 7, 8, 9, 10, and kind of 7, 6, 5, 4. So now I'm ready to kind of do the same thing coming up around this way, like picking up point 11 now. This was 7, 8, 9, 10. I'm ready for point 11. So point 11 is the same as point 9 in this drawing. So that would be point 11, or also point like 3 over here. All right. And then I'd be ready for the information on point 12, which is right here. So 12. I think it's when I copy the piece that I just missed that a little bit, but yeah, I didn't do my. I should have dropped that one too, where on the next line, which was kind of like 0.2 there. So 7, 8, 9, 10, 11, 12, back to 0.1, and this would have been like 7, 6, 5, 4, 3, 2, and back to 1. This is where, and it's the same length as 7. So 1 and 7 share the same information in this view. So all right, excellent. Yeah, those look like I've hit my node points. Like I said, if you miss them just by a little bit, it's not gonna affect my pattern too detrimental. One thing that does is I always make sure at least the outside ones are connected to make as I do a polyline edit, I can make one shape to actually copy and move and make a cut file if I need to. So let's go ahead and do my polyline and go line to line on all these points, and that's kind of what that branch layout looks like. So I'll start it here. This one I am going to do an arc and a second point. So arc, second point, and maybe I'll just kind of like snap that off there, and then do an arc and a second point. Well, actually, I think I'm going to escape that, and maybe I'll start the same thing over here. There's really no right or wrong way to make these, just kind of connect them. You could start any number of ways. I actually didn't quite snap that thing to the point there. I mean, if I was hand drawing these patterns, I would use one of those French curves and kind of try to line up as many of these I could before I would draw my line. Then I would cut them out and then transfer that to metal and, you know, use a plasma or a speedy cut on a grinder, a thin disc cut on a grinder. So there's going to be some, I mean, there's going to be some variation there. And then I've got to do a little bit of maybe sanding and finish work before I'm ready to actually make a weld joint out of that. So, I mean, you know, the welder deals with a little bit more room for error there than, you know, than machinists are used to. And it's just the nature of how we fit stuff up is, you know, our tolerances are a little bit sloppier, but I still, you know, think of a 30-second in my mind, you know, and try to get nice tight weld seams. So, yeah, I'll show you like another, like I could have maybe started the pattern on the point here and done an arc and second point and maybe done it like this. Well, see, I'm not going to really like just snapping that to that. That's another look, and maybe that looks fine. I kind of like zoom back and see if it looks like it makes the transition. Maybe I like that better. So, you know, that's kind of two different looks. If I look at that, you can see that this one maybe jogs in just a little bit more from that line to that line. I mean, there's just, I don't grade these super hard when that's that case, you know. It definitely looks better this way than it does just a line to a line to a line, you know. So if it's just straight line segments and they're kind of choppy. So, you know, either of these I'm okay with. I think I do like the first way better. And maybe starting at this point and arc second point back into the middle. I mean, it doesn't exactly look symmetrical. That should look really symmetrical in between there. So let me even try a different one. Maybe it's like, maybe if I start the pattern here, with my second point being this, the low part of my pattern, and then see if I second point again, I can see if it will go. If not, then I'll just pull that as a line. Ah, see, that works pretty good. So now I'm gonna maybe that's the most symmetrical looking pattern that I've done yet. Maybe I'll start it here. Use this as my second point. Yeah, something like that. You can experiment and oh, that one I didn't even get my second point chose, so I'm sure there's easier ways to do. To get something you'd be happy with. But that's sufficient for me, I think. I'm gonna switch these to a solid line that is red. Yeah. Keep the outsides of my pattern red. Those represent my quarter marks, so I like that. This one I could, if I was keeping in, you know, this one I could either make a center line yellow or quarter line, you know, green or yellow, doesn't matter. It's fine. Just kind of a breakup, and it just shows me that's quarter of the pattern, quarter of the pattern, quarter of the pattern. Get this really symmetrical looking sweep. Really, like, it's symmetrical all the way through half that pattern. So, all right. I think I'll go ahead and end this video here. I think I'm going to do one more part. Part 3 is going to be just the header development. So stay tuned for that, and we'll pick up in part 3 for the header. There's our branch. Really, for a lot of reasons, that's all I would need. I could print this out of paper, go wrap it around my 3-inch OD tube, mark that out, and have this kind of a have this to where I could cut it out of my 3-inch OD tube, and then I could just butt that into my header and decide what I got to do, whether it's a passing through for a process, or if it's just kept solid for structural. Anyway, I will do the part 3. Will be the header. So we'll see you then.